Good day, good day, good day, good day, good day. Welcome to Yebo Tutor Livestream. Help. It's been a minute, but the good thing is that we are back. Wake up your friend, wake up your roommate, and tell them that it's about to go down. We are back like we have never left, and now we are ready to prepare for the final exams, which is about to start. So today we'll be looking at the Gauteng paper and we're gonna focus more on the calculus of the questions, since other people have already requested that we start with calculus in the WhatsApp group. So in other words, if you also have a topic which you want us to look at during this week, drop a comment on the comment section or join the WhatsApp group and you can remember to interact and drop your comment or drop your topic in there. Without wasting much time, let's delve straight into calculus. If you need all the basics of the calculus and all the step-by-step stuff, also in the Yebo Tutor videos, we have a video which explains everything about the calculus from first principle and how to derive the power rule and applying all the rules which we have until we do the calculus function. Then everything will be sorted for you. But in these tutorials which you're gonna have from this week, this whole week, next week, it's more into practice questions and timing ourselves that we work on time. Question 8. Question 8. If f of x is equal to negative 2x, so we are given f of x which is equal to negative 2x squared plus 3x. Now they say that find f, the first derivative of x from first principles, which means we need to use the long method without doing shortcuts. So let's do that first quick because we don't have time. Of course, we will need to have our f of x plus h, which will now be equal to negative 2. Where there's x, now we are replacing with x plus h, of course, squared plus 3 multiplied plus x times h. That will be negative 2, of course. That will be your x squared plus your 2xh plus your h squared, of course, plus your 3x plus your 3h. And of course, multiplying all through by negative 2, that will be negative 2x squared minus 4 xh minus 2h squared plus 3x plus 3h. Now we have our f of x plus h. We also have our f of x. Now we know that from first principle, the f prime of x from first principle is the limit as h approach 0 of f of x plus h minus f of x all divided by h. And what is our f of x plus h? We have calculated it to be there. So now we come and have our limit as h approach 0. Then in the position of f of x plus h, now we substitute with negative 2 x squared minus 4xh minus 2h squared plus 3x plus 3h minus, what is our f of x? Our f of x is given as this, so that will be minus, then we put a bracket, negative 2x squared plus 3x. Of course, we divide all through by h. Then of course, if we remove and we multiply all through by this negative times negative, that's going to give us a positive there. Negative times negative, that will be negative, so that will be negative, so that you remove the brackets, that will be positive over there. So now we can see that this and this is equal to 0, this and this will be equal to 0. So now we'll be left with the limit as h approach 0 of negative 4xh minus 2h squared plus 3h, or divided by h. And you can see that on the numerator we have a common factor which is h, so let's take that out. So that will be h negative 4x minus 2h plus 3. Now of course all divided by h. H and h cancel each other, then that will be your limit as h approach 0 of negative 4x minus 2h plus 3. Now substituting h is equal to 0 over there, that will be negative 4x minus 2 times 0 plus 3, then that will be equal to negative 4x plus 3. So that will be your first derivative from the first principle. Simple, straightforward. The most important part is to determine your f of x plus h. Then after you know your f of x plus h, then after that you'll be ready to solve the question which you are given. Now let's move on to question 8.2. 8.2, we are given, let's maximize the screen. So on 8.2, we are given f of x, which is equal to 3x squared divided by 2 minus 24 root x. And now they want us to calculate f prime of 9, which means they want us to find the first derivative of x. Of course, we cannot use the first principles in this instance. As you can see, we just have to use those straightforward rules which have already been taught in class. So let's minimize that. So we can rewrite our f of x as our 3 over 2 x squared minus 24 x to the power 1 over 2 because we now need to remove the square root. So now we can now be able to find our f prime of x using the power rule. So that will be 2 times 3 over 2, and that's straightforward thing because we know that that's the same as 3. Then of course you'll be left with x there. Then of course minus 1 over 2 times 24, 1 over 2 times 24, that's 12. That will be 12x. Then 1 over 2 minus 1, that's negative 1 over 2. Now the question was saying you need to find f prime of 9, which means where there is x, now we are substituting with 9 minus 12, 9 to the power negative 1 over 2. Then after that we can use our calculators then on that point. So this was a straightforward question. 3, 9 minus 12, 9 negative 0.5. Then I'm getting my answer to be 23. So that was a straightforward question over there. Okay, moving forward to the next part of the question, which is question number 8.3. Let's maximize the screen. Here we go. 8.3. A function g of x is equal to ax squared plus b over x has a minimum value at x is equal to 4. The function value at x is equal to 4 is 96. Calculate the values of a and b for 6 marks. This is a nice, interesting question. So what we have taken note of this English which they have given us is to understand only few things. Then after we understand the few things, then we can be able to solve the question. So the first thing we know is that we are given that the minimum value in this question is at x is equal to 4. That's what they told us. And we know that we need to find the g prime of x, which is equal to 0 at x is equal to 4. So now let's do that. Okay, so we are given g of x, which is equal to ax, let's double check that, ax squared plus bx. Now that part can be rewritten as, also it's b over x. Yes, this can be the same as g of x is equal to ax squared plus bx to the power negative 1. Now we can look for our prime, g prime of x, which will now be equal to your 2ax plus, that will be negative bx to the power negative 2. Then on that point we say that we need to look for our g prime, or the g prime of x will be equal to 0 at minimum. We know that. And of course that would just be equal to 2ax minus b x negative 2 is equal to 0. And also we say that at this minimum our x is equal to 4. So now we substitute here in this equation with x is equal to 4. So that will be 2a times 4 minus b 4 to the power negative 2 equal to 0. Then that will be 4 to the power negative 2. That's 1 over 4 squared. That's 1 over 16. So now we end up having 8a minus b over 16 equal to 0 over there. So this will now be 16 times 8. 16 times 8. 128. If we multiply all through by 16, a minus b is equal to 0. So that can be our equation 1. And also in this equation, they told us that the functional value at x is equal to 4. At x is equal to 4, we were told that our g of x will be equal to 96. Okay, so now this is easy because we are already given our g of x, which is equal to ax squared plus b over x. So which means at g is equal to x is equal to 4. So that will be a 4 squared plus b over 4 is equal to 96. So that will be your 16a plus b over 4, which is equal to 96. Then from that point now we can now be able to calculate whatever question which we want to calculate, because we already have the values which we are looking at. So if we multiply all through by 4 on both sides, that will be 64a plus b, to remove this 4 over as the denominator. So we multiply everything by 4. Let's use a different marker. By 4. So this and this will cancel, then I left with b. Then 16 times 4 is 64. The same thing which we did also above there. Then 96 times 4, that will be 384. Now this can be our equation 2. So now we have equation 1 and equation 2. So we can make B the subject of the formula on both instances, okay? So that can be 64A minus 384 is equal to, nope, B is equal to 384 minus 64A. That can be equation 3. Then also B is equal to, from the first one there, which we got there, so that can be 128A is equal to B. So 128A is equal to B over there. So this can be equation 4. So we can equate 3 to be equal to 4. So that will give us 128A is equal to 384 minus 64A. Then of course 128 plus 64, 128 plus 64. That's giving me 192A, which is equal to 384. We divide all through by 9, 192, 192. Then our A value will be equal to 384 divided by 192 over there. Then we're getting our A value, which is equal to 2. Then therefore our B value will be equal to what? We say that our B is equal to 128. So let's just write that, substitute A is equal to 2 in our equation 4, okay? So that would be 1B is equal to 128A, and your A in this instance is 2. So 128 times that 2, that will give you 256. So our B value, which we're looking for in this instance, is 256. Easy stuff. So now you have your 15 marks. Then both of us, we are all happy. If you are happy and you know, just say yes in the comment section. Now let's move on to the next part, or to question number 9, where now we are diving more into the functions which we are having. Again, stop me anytime, drop your question, and we can be able to entertain it and engage on it. The graphs of g prime of x is equal to ax squared plus bx plus c, and h of x is equal to 2x minus 4 as sketched below. The graph of g prime of x is equal to ax squared plus bx plus c is the derivative graph of a cubic function g. Now, the graphs of h and g prime have a common y-intercept, which is at point E. So we can already see that point E is a y-intercept, which means that the x value is always equal to 0 over there. Then of course we are also told that c is negative 2 is to 0. As you can see, that's an x-intercept over there, and d is 6 is to 0. Again, that's an x-intercept of that parabolic function which we have over there. Then of course point A is the x-intercept of h. Okay, we can see that, which means the y value of point A is already equal to 0, because we know that the x-intercept, we let y to be equal to 0, and point B is the turning point of the function g. So which means that point B can be calculated by saying x is equal to negative b over 2a, and of course you can substitute that x value in the original function so that you can get the y value of the turning point. Now, proceeding forward, we can see that we are also told that line AB is parallel to the y-axis. This is interesting. Parallel lines. Now, write down the coordinates of point E. We said point E is the y-intercept, and we know something about the y-intercept. And you can see that point E is also in the function of h. And in the function of h, we are given, let's write this down. Question 9. We are given our h of x, which is equal to 2x minus 4. We are also given our g prime of x, which is equal to ax squared plus bx plus c. So now on number 9.1.1, they want the coordinates of E, and they already told us in the reading there that point E is the y-intercept, which means it has the x value by is the y-intercept, which means the x is equal to 0. So now we only have to calculate the y-intercept over there. So calculating the y value is easy, because we already know that x is equal to 0, and we can see that point E is also located in h of x. So we can now substitute our point E in h of x, okay? So that would be, where there is y, we put y is equal to 2, and on the position of x, we're putting 0 minus 4, so our y will be equal to negative 4. So then therefore, our coordinates of A will be at 0 is to negative 4. Tango means thank you, and you get your marks. Oh my word, I'm sorry guys, I didn't remove the marks from screen. So we are saying that at point E is a y-intercept, and which, since it's a y-intercept, which means x is equal to 0. So substituting that x is equal to 0 in the function of h of x, will be able to get our answer to be negative 4. So the coordinates of point E is 0 is to negative 4. Now moving on to 9.1.2, the question goes as follows. Now, 9.1.2 says that determine the equation of the graph of G prime in the form of y is equal to ax squared plus bx plus c. We can see that that form of the equation is given in terms of the standardized form of a parabolic function. And what we know about that G prime, we know that that G prime is a parabolic function, and we are given the 2x-intercept, which is -2:0, as well as point D, which is 6:0, and of course point E, which we have already calculated. So this is already easy, and we can calculate this equation by using our x-intercept formula of the parabolic function. Minimize that. So when we minimize that, we know that now we are on 9.1.2. We know that y is equal to a x minus x1, of course, x minus x2. This is what we call the x-intercept formula. We are given the two values of the x-intercept. We are told that it's at x is got -2:0 and also at 6:0. So these are our x-intercept, which we will be using so that we can be able to get the answer. So now let's substitute so that we can get the answer over there. So that will be y is equal to a x plus 2, of course, multiplied by x minus 6. Then of course we are also having the point E, which is 0 is 4, -4. So now we can now substitute point E, right, in this equation. Let's say this is equation 1, in equation 1 over there. So on y now it's -4 equal to a. On the position of x we are substituting with 0, so that will be 0 plus 2 multiplied by 0 minus 6 over there. So that will be -4 is equal to a 2 by -6. That will be -4 is equal to -12. A divided by -12 divided by -12. Come on! Then your a value is equal to 1/3. But this is not what they say. They say that leave your equation in form of ax squared plus bx plus c, which means we need to finalize our equation in terms of the standard form of a parabolic function. So by now we know that therefore y is equal to 1/3 x plus 2 multiplied by x minus 6. Okay, so now we can now solve that 1/3. Then looking at that x times x, that will be x squared. X times that will be -6x. Positive 2 times that will be positive 2x, of course, minus your 12 over there. Then that will be y is equal to 1/3. Of course, we still have x squared. Then 2 minus 6, that's -4x minus 12. Then now we can now multiply all through by 1/3. So that will now end up giving us 1/3 x squared minus 4/3 x, then 1/3 times -4, that's -4 over there. So this is the standardized form of this equation. So breaking it down again, we say that in order for us to get the standardized form of the parabolic function, we know that we are given the 2x-intercept, which is at -2:0 as well as 6:0. So having those two coordinates, now we can be able to calculate this, because we know that we can use what we call the x-intercept formula since this is a parabolic function. So we use the x-intercept formula. We say that y is equal to ax minus x1 multiplied by x minus x2. Then of course we can get the value, since we already know another point in the function, which is point E, which is the y-intercept, which has the coordinate of 0 to -4. Then we substitute there. Then now we have our formula in x-intercept formula. But the question wanted it to be in the form of ax squared plus bx, which means now we need to solve our equation so that it can be finally making sense. And when we did that, y is equal to 1/3 x squared minus 4/3 x minus 4. Dango! Moving on to the next question. Maths is nice. 9.1.3. Write down the coordinates of the turning point of G. The turning point, guys. This is easy stuff. We know something about the turning points of G, and we know that the turning points of G is always when we find our G prime to be equal to 0. This is so something else. So on 9.1.3, we know that at turning points, always your G prime of x is equal to 0. So in this instance, our G prime of x is given as 1/3 x squared minus 4/3 x minus 4. So this should be equal to 0. Of course, we already know that this is giving us our x minus 2 and x plus 2 and x plus minus 6. So this is the same as your 1/3. Then that would be your 1/3. You still remember x plus 2 and your x minus 6, which is equal to 0. So divide all through by 1/3, that should be 0. So your x will be equal to -2, or your x is equal to 6. So which means our x turning x values of the turning points will be at x is equal to -2 and x is equal to 6. Straightforward stuff. straightforward stuff, because you know that at turning points g prime is equal to 0. Then we solve that part here, as you can see over there. Then we can get the answer. Now write down the x-coordinate of the point of inflection of the graph of G. Point of inflection now of the graph of G is now something else. How do we find the point of inflection? We know that in order for us to find the point of inflection of a function, we need to find our f prime prime. Okay, so if we can find our f prime prime, then of course now we can be able to find our point of our point of inflection. So that would be 9.1.4. So for point of inflection, basically that should be, let's see, remove that so that people can see the screen. So we know that that will need us to find our g prime prime of x. So in this instance, we know that our g prime of x is equal to 1 over 3 x squared minus 4 over 3 x plus minus 4. So that would be the g prime prime, which means that would be 1 over 3 times 2. So that would be 2 times 1 over 3 times 1 over 3. So that would be 2 over 3 x minus 4 over 3. So we are saying that at point of inflation, we know that our g prime prime of x is always supposed to be 0. So that will now have our 2 over 3 x minus 4 over 3 is equal to 0. Then now we solve for x. So that will be 2 over 3 x is equal to 4 over 3 over there. If you multiply all through by 3, that will be, or we can just divide by 2 over 3, divide by 2 over 3, then your x value is equal to 2. So the point of inflection is at x is equal to 2. It's an easy question again, because we know that we need to find our f prime prime of x. Now let's look at 9.1.5. Okay, explain why G has a local maximum at x is equal to -4. Guys, it has a local maximum at x is equal to -2, because we can see that when, let's just write that English, let me write it for you over there. Okay, so we can see that for x is less than -2, g prime of x is greater than 0. So we can see that the gradient of G is positive, and for the values of x immediately to the right, immediate right of -2. So we can see why that is our answer, and we can explain it in that way. Okay, now given h of x is got 4x cubed plus 5x, substantiate whether it's possible to draw a tangent to the graph of h that has a negative gradient. Okay, 9.2, that's a substantiation question. This is again easy, because we can find the gradient, and we know that the gradient of the function is always the f prime. So if it's less than 0, then we can be able to solve that and substantiate that. So let's do that now. So that will just be easy stuff, so that we can say that a negative gradient. Okay, so we know that we need to look for our first derivative there, so that we can have the function. So we're given h of x, which is equal to 4x cubed plus 5x. So we can say that our h prime of x is equal to your 12x squared plus your 5, of course. Now, and your h prime of x should be less than 0. That shows us our negative gradient over there. So that will give us 12x squared plus 5 is less than 0. Then we can see that then therefore our 12x squared is less than -5. Then your x squared will be less than -5 over 12. So we can see that then therefore this is impossible. This will be impossible for a square. This is impossible because a square is always greater or equal to 0. So now you have the 12 marks, you have the 15 marks. What else do you want? You already have 27 marks in the pocket with you. Now let's look at the last question, which is question 10. Now on question 10, the diagram below shows the plan of a veranda which is to be built onto the corner of the cottage. A railing A, B, C, D, E is to be constructed and around the four edges of the veranda. It is given that AB is equal to DE is equal to X. Okay. AB is equal to DE is equal to X. Okay, no, it's fine. BC is equal to CD, BC, where is BC? So that BC is equal to CD, again is equal to Y, and the length of the railing must be 30 meters. Calculate the values of X and Y for the veranda, which we have the maximum area. So now this is where the fun begins, okay? So what is important is to understand that FE, first point, is equal to FA, okay? So that can be great for us to understand that your FE is equal to, let's see if I minimize that. Here we go. Yes, so you can see that our FE is equal to our FA, and that will be equal to our Y minus A X. That's the first point, which is important. Now let's calculate everything now. So when you say AB plus your BC plus your CD plus your DE, so that everything is calculated, so that you end up having us our 2X plus our 2Y. Okay, then from that point we know that the total length, they say that this should be equal to 30 meters, so our 2X plus 2Y is equal to 30 over there, so that would be your 2y, which is equal to 30 minus 2x, then you divide all through by 2, then your y will be equal to 15 minus x. Okay, so that will be what we have over there. So of course now we know that we can have our area of a to the ax as a function, that will be y squared minus your y minus x, then of course we square that, then of course that will be the same as y squared minus, then multiplying all through this, that will be minus your y squared plus 2xy minus your x squared over there. Then of course this is the same as y squared minus y squared, it's 0. So now we end up having your 2xy minus x squared. Then from that point we know that that will be the same as your 2x in the position of y. We've already calculated your y above, and your y was 15 minus x, so that will be 15 minus x, of course, minus x squared. Then removing the square there, that will be 30x squared. So 30x minus 2x squared minus x squared over there. Then after that we can end up having our 3x squared there. That will be 30x minus 3x squared. And of course we know that for maximum, so this is our a of x. Okay, so for maximum we know that we need to have our a prime of x to be equal to 0. So let's find our a prime. A prime of x will now be this was 30x, so that will be just 30 minus 6x. Okay, so for maximum that will be a prime of x is equal to 0, so that will be 30 minus 6x is equal to 0, then 30 is equal to 6x, then divide both sides by 6, divide both sides by 6, then definitely your x will now be equal to 5. Now that our x is equal to 5, oh my god, we can now find our y value, because we know that y is equal to 15 minus 5. Of course, then your y will be equal to 10 meters. So your x value is equal to 5 meters and your y value is equal to 10 meters. Then this is calculus. You get your 35 marks. That's already level something. Okay guys, this is it. This is your calculus questions which we're looking at today. Please, if you have any question, do comment on the comment section so that we can be able to engage. Also type in the WhatsApp group so that we can be able to see where we can assist each other. From me, your host and the most, have a great evening, and of course let's engage in the WhatsApp group. Papers are in the WhatsApp group, so don't forget to tune in and join the WhatsApp group. Tango means thank you.